Good morning everyone. In this session we are going to solve Unit 1 problems. Okay. So the problems on problems like impact stress and a series of failure problems, okay. Simple stress problems. Okay. So let us see one by one. So first of all, impact stress problem. A weight of 1400 Newton is dropped onto a collar at the lower end of a vertical steel shaft of 3 meters long and 25 mm diameter. Calculate the height of drop. Okay, the height of drop if the maximum instantaneous stress produced is not to exceed 120 MPa. Take Young's modulus E is equal to, so Young's modulus E is equal to 2.1 into 10 to the power of 5 MPa. Okay. So actually this problem comes under impact stress problem. Okay. So impact stress. This model is related to impact stress. So what is, first of all, what is impact load? Okay. So impact load means the load acting with a certain initial velocity is known as impact load. Or we can, in other words, we can say that the load acting from certain height. Okay. So on any body or any component is known as impact load. Okay. So generally we have a formula for impact stress. Okay. So here you can see there is a load W. Okay. So here there is a bar. Okay. There is a bar and a load acting at a certain height on a collar. Okay. Here the load W acting from certain height. That height is denoted by h, small h. So here we have to calculate this h value, height. The height from which this weight is dropped or this load is dropped on a collar. Okay. So this collar is fixed to the this bar, metallic bar. Okay. So we have to find this h value. Okay. So we have a direct relation for impact stress. Okay. The impact stress sigma I is equal to. So let us see. First of all, let us write this given data. So what is the given data here? So here the given data is the load. So first of all, load is given. The load. So load W is equal to, so given data load W is equal to, so W how much? 1400 Newton. And next, so diameter of the shaft, suppose this is shaft, okay. So this is diameter of the shaft, small d. So diameter is given, okay. So diameter D is equal to diameter of the shaft, diameter of the rod. D is equal to 25 mm diameter, 25 mm diameter. And next, and as well as this length of the, and also the length. So length of the shaft. So length of the shaft is 3 meters. So convert 3 meters to mm, 3000 mm. So just multiply with 1000. Okay. Then we can convert that meters to mm. And we have diameter, length, and still any other data. So here instantaneous, the maximum instantaneous stress produced due to this impact load. Okay, what is the stress? Impact stress. So impact stress sigma I is equal to how much? 120 MPa. So 120 MPa or 120 Newton per mm square. Again, Young's modulus is also given. Young's modulus is equal to how much? Young's modulus 2.1 into 10 to the power of 5 Newton per mm square. Newton per mm square. So here the unknown is height. So we have to calculate height of the drop. Okay. So it means the height from which this load is released. Okay. This load is released. So we have to calculate h. We have formula instantaneous stress or impact stress. Impact stress. So direct formula. Impact stress sigma I is equal to, so W by A 1 plus root over, again 1 plus, so we have a formula. What is that formula? 2. So here we have 2 into, so okay, 2H A by W L whole. So this is the formula for impact stress. Okay. So here we know the W, and again we can calculate the area of cross section from this diameter. Okay. So circle shaft means circular cross section. Okay. So diameter is given. So the shaft is in circular cross section. So area is equal to pi by 4 into d square. Okay, so W is already given, load, impact load 1400 newtons, and 2 into H is the unknown. Here H we have to calculate this H value, height of drop, and area of cross, okay, cross sectional area, okay, and time smallness is given, and length of the shaft is also given. So simply substitute all the values and calculate this H value. Okay, sigma here, sigma is equal to, just substitute, sigma is 120 MPa. So sigma is Chadmani. So 120 MPa impact stress is given, instantaneous stress. Okay, due to this drop, this much stress is produced. Okay, so 120 is equal to load. What is the load? So here load is equal to how much? So load is 1400 Newton. 1400 divided by area. So area of the shaft. So pi by 4 into d square. Pi by 4 into, what is the d square? D value 25 mm. So 25 mm whole square. 1 plus root over 2 into, just erase this diagram, just wait. I just want to erase. Okay, fine. So 2 into, so H is unknown, okay, and area, again area pi by 4 into 25 whole square into Young's modulus. So Young's modulus value 2.1 into 10 to the power of 5. Divided by W means 1400, okay, so 1400 into length 3000. So 3 meters is given, but we have to convert it into, mm, okay, so 3000. So now solve so now take this term, okay, entire term 1400 by pi by 4 into 25 square, okay, to the right hand side, so sorry, left hand side, then we will get some value. Okay, so let us solve this, okay, so I will write that relation. So if you take that 1400 by 25, then pi by 4 and 25 whole square to the left hand side, then we will get 120 into, okay, so pi into 25 whole square divided by 4 into 1400. Okay, if you rearrange this terms, so rearrange చేసుకుంటే మనకి రాస్తుంది. Okay, so here again, here we have 1 plus root over 1 plus 2 into h into pi by 4 into 25 whole square, okay, into 2.1 into 10 to the power of 5 divided by, what is the value of W? 1400 into, so L 3000. Okay, this is the terms. These are the terms. Okay. Now here we have to calculate h. First of all, solve for this term. So you will get the value 42.05. So after solving this term, this term solve just the values. Okay. So again 1 plus. Okay. So here root over. So if we solve this entire term, you will get 49.062 h. Okay. So after solving the entire this term, you will get this one. So let's take this one to the left hand side, then it becomes 41.05, 42.05 minus 1. Okay. So root over 1 plus 49.062 h. Now squaring on both sides, apply squaring on both sides. Now squaring on both sides, we get 41.05 whole square, and the square and root cancel. Square, already square is there, so square and root, the square and root cancel. Okay, root is already there, so square and root cancel, and then the remaining value is 49.062 h. 49. Okay, so now so 41.056 value 16, so okay, 85.10, okay, is equal to 1 plus 49.062 h. Okay. Now again take that remaining, that 1 to the left hand side. Okay. If you take that 1 to the left hand side, so then you will get 49.062 h is equal to, so 1684.10. Now h is equal to 1684.10 divided by 49.062 h. Sorry, 060. So So if you solve this expression, you will get, so the value height h is equal to 34.33 mm. Hence, height of drop is 34.33 mm. This is the answer for the given problem. Okay, thank you.